VAP number 6 tells us to consider the differential equation dy over dx is equal to x over y, where y is not equal to 0. And it gives us the slope field of this and the 2 points of 3, -1, and 1 and 2. And then it asks us to sketch the solution through both of these points. Now we see both these points are labeled by the little dots on the graph. So starting with the first one, we can sketch a rough visual of what the shape of this graph will be like by following the trend of the slopes, and the same goes for this point right here. And now part B asks us to find the equation for the tangent line to the solution curve that we created by passing through the point 1, 2. Now we can know that the derivative is the slope of our function, so we can plug that initial condition of 1, 2 into our differential equation. And since we know that this is a slope, we can set that equal to m and use our initial condition once again to put it in point slope form, giving us y minus 2 is equal to 1/2 times the quantity of x minus 1. And now part C asks us to find the particular solution to this function given the initial condition of f of 3 is equal to -1, and it wants us to state its domain. So to solve this differential equation, we have to start by isolating or separating like variables to each side of the equation. So we'll get y dy is equal to x dx. Then we're going to go ahead and take the integral of both sides, which will give us half y squared equals half x squared plus c. And now, since we are solving for the particular solution, we can go ahead and isolate c right here and plug in our initial condition of 3, -1. Solving this down will give us a c value of 4. So we can go ahead and plug that value back into the equation we solved for earlier. So now what we want to do is isolate y, so we can start by multiplying by 2 on both sides. And then we're going to go ahead and take the square root of both sides to isolate y further, and that'll give us y equals plus or minus the square root of x squared minus 8. So in order to figure out which one's ours, we can go ahead and graph it, and we can see that the positive graph in red does not include our initial condition like the blue one, which is negative, so we're going to go with negative. And tracing our graph, we can see that our domain is going to be when x is greater than 2.83 and x is less than -2.3, and we can see that this satisfies our equation in the blue.